And now it's time to review for exam number 3. Find all of the solutions in 0 to 2 pi. So this right here means make sure that your calculator is in radians mode. That 2 right there means we're going to be finding twice as many answers as usual. So most likely instead of 2 answers, we'll be looking for 4 answers. And then the first thing to do is subtract 4 from both sides. So it's negative 7 sine of 2x equals a negative 3. And then, to isolate sine, divide both sides by negative 7. So then we're left with sine of 2x is equal to 3/7. So to visualize what's going on, if you look at the graph of sine between 0 and 2 pi, it looks like this. And then this part is saying when you look at the sine graph, when does it equal 3/7? So 3/7 is approximately right here. And if you draw a line straight across, there's going to be 2 solutions. The first solution is going to come from using sine inverse. So then take sine inverse of both sides, and it's going to say 2x equals sine inverse of a 3/7. So right now my calculator is in degrees, so I need to change that over to radians. And then do sine inverse of 3/7. And it says it's 0.443. Now with a number like 3/7, I'm pretty sure that's not pi over 12 or pi over 6 or something, but just to verify, if you divide that by pi and you tell the calculator what fraction is that, it cannot come up with a fraction because there isn't one. So we just keep that answer, 0.443. Now this second one over here, this one is to the left of pi, so that's going to be pi minus 0.443. Pi minus 0.443 is a 2.699. Now, that means that 2x is equal to a 0.443. 2x equals a 2.699. And I know that you want to divide by 2, but be patient because we need to find the other 2 solutions. So if you continue the sine graph out, and if you continue this horizontal line out, there's 2 more answers right here and right here. And because the period of sine is 2 pi, to get from these 2 answers to the next 2 answers, all you have to do is add on 2 pi. So for each one of these, add on 2 pi. So 2x equals a 0.443 plus a 2 pi. 2x equals a 2.699 plus a 2 pi. And then, once we've got the 4 answers, now divide them all by 2. So this part, I don't even have to get the decimal answer. I can just type it in the calculator like that and then say divide by 2. So the final answers are going to be the 0.443 gets divided by 2. Oh, that's a cool number. 0.222. And then the 2.699 gets divided by 2. And then take 0.443 plus 2 pi. So just like I have it right here. And put it in parentheses and divide by 2. So x equals 3.363. And then for the last one, 2.699 plus 2 pi parentheses, that gets divided by 2. 4.491. And there are the 4 solutions. Now, if I wanted to check the answer real quick, I could just graph the original problem, which said 4 minus 7 sine of 2x. And then, when does that equal a 1? So change the window to go from 0 to 2 pi. And then it's where it equals 1. So if I put 0 to 5, I should definitely be able to see where they intersect. So there's one answer, 2 answers, third answer, fourth answer. So instead of testing each and every one of these, I'm going to test this last one. Most likely, if I got that one right, I got all the rest right. So go to trace and type in 4.491, and that should be that point right there. Spot on. Correct. Then for example number 2, convert these to polar. In other words, this is going to be in the XY system, and then change it to the polar system, which is r comma theta if it's a point, and then it could be a function r equals something with theta if it's a function. The first one is a point. How about -2 comma 5? So this is saying what x is, and this is saying what y is. And we could use formulas like x is equal to r times cosine of theta. We can use y equals r times sine of theta. We could also use x squared plus y squared equals r squared. And then also y divided by x is equal to tangent of theta. So in order to solve for theta, this is a good choice. So you just put the y over the x, set it equal to tangent. So tangent of theta equals the y over the x. And then find tangent inverse of that. So tangent inverse of 5 divided by -2. And in this problem, it didn't say if you have to use radians or degrees. So since my calculator is already in radians, I'll just leave it like that. So it's a -1.19. So theta equals a -1.19. Or if you did want to work in degrees, then change this to degrees, redo the same thing, and it says it's -68.199 degrees. Now, there is a little bit of thought that needs to go into this, because if you look at this point, -2, 5 is in quadrant 2. But -68 degrees is actually going this way. So it's going this direction to compensate for the negative. And then that would be 68.199 degrees. But we need it to be going this way. So what we need to do is, this angle and this angle are called vertical angles, and they're going to be the same. So that means that this is 68.199 degrees. And then what we really need is going from here over to that. So that means that theta would actually be 180 minus the 68.199 degrees in order to get into the second quadrant. So 180 minus 68.199, 111.801. There, that's part of it. Now the other part is we need to find r, and for that I'm going to use this formula. So r squared equals the x squared plus the y squared. And then this is going to be 4 and 25, so that means that it's 29. And then we're going to use the positive square root. So then the final answer would be r, and this square root of 29 can't be reduced, so you could just leave it like that, or you could put the decimal form of it if you want to. And so there is the r and the theta, where r goes first, theta goes second. Then for part B, so for number 2, part B, also convert to polar form. So this one is y equals 2x squared minus 1. So again, we have these formulas to work with. And so I can just basically use these two and substitute in place of x an r cosine theta. So that's going to go in there and it's going to get squared. And then here you could replace y with this, r sine of theta. So y gets replaced with r sine of theta. X gets replaced with r cosine of theta. Then it has to be squared and minus a 1. So this one, I could clean it up a little bit and say it's 2r squared cosine squared. And this one is r sine of theta. And this one has r squared, but this one has r, so they're not going to combine. And so, and also a cosine squared and a sine, you're not going to be able to factor out or combine. So it looks like this one, we're already done. Then for example number 3, convert the other way around. Convert to rectangular form. So in other words, you're given an r and a theta, and then find x and y. So with the theta, it could be in degrees, but in that case, it would have a little circle right there. Since it doesn't, that means that theta equals a 7 in radians. And this is just that r equals 2. So for the third time, we could use the formula x equals r cosine theta. And we could also use y equals r sine of theta. And then just plug in the 2 and the 7, and the 2 and the 7. So x equals 2 cosine of 7. I have to make sure that the calculator's in radians. And for the y, it's going to be 2 sine of 7. Sorry, trying to get rid of that glare. So 2 cosine of 7 and 2 sine of 7. So let's see, the cosine, that's x, so that goes first. So 1.985, and then the y is from the sine, so that's 0.244. And now we're ready for part B. What if it was a function? So again, convert to rectangular form. How about if it's the function r equals secant of theta? Well, if you look at these formulas that we have to work with, none of them say anything about secant. So what we need to do first is use a trig identity that secant is 1 over cosine. And then what I could do is multiply both sides by cosine of theta, which basically transfers it over to the left side. It's going to be r times cosine of theta equals 1. And then that matches that. So r cosine of theta can be replaced with x. And then once the r and the theta are gone, that's it. Now I could check this answer by graphing, because x equals 1 means there's a vertical line right here where x equals 1. And if I graph it in polar form, it should give me the same thing. So y equals, oh, I need to change this, so change the mode. I'm going to work in radians, and then change it to polar form. Now it should say r equals, très bien. And the calculator doesn't have secant, so I have to go ahead and do this, 1 divided by cosine. And then for the window, since we're talking about a trig function, we should go from 0 to 2 pi. And the x value needs to include 1, so if I go from 0 to 2, that should be good. And then the y values, I'm just going to use -5 to 5, because if I can see that much of it, I probably got it right. And then it should make a vertical line, goes up, goes down. Got it. Bob's your uncle. Okay, then on to some triangles. So for example number 4, how about if this was the triangle, this side is 53, this side is 21, and this side is 40. Then how much is this angle right here, theta? So this is either the law of sines or the law of cosines. But the thing with the law of sines is you would go sine of theta divided by 53 equals sine of a blank divided by 21. And because this one's blank and this one's blank, we can't use law of sines. We need to use the law of cosine. So you start with the given angle, go across from it, and that's where the whole formula needs to start, with the 53. So it's going to be 53 squared equals, and then the other two sides squared, and then minus 2 times the 40 times the 21, and then cosine of theta. Then we need to do the algebra to start solving for cosine of theta. So we'll need to subtract this 40 squared and subtract 21 squared. So there was already a 53 squared on the left side. There's that glare again. Okay, there we go. And then subtract 40 squared and subtract 21 squared. It leaves 768. And then for this part, I'm just going to leave it like this. And then I'm going to divide both sides. So I'll just divide both sides by this in order to isolate the cosine. And so that is a 768, which gets divided by a -2 times 40 times 21. And then put that in parentheses so that it divides by all of that stuff right there. And then it equals a -0.457. So then it's going to be cosine of theta equals a -0.457. So then take cosine inverse of both sides. And when dealing with triangles, we usually use degrees. So change the mode over to degrees, and then do the cosine inverse of -0.457. And so the theta is 117.194 degrees. And then for number 5 with vectors. So given the vector u, which is -1, 8, and vector v, which is 2, 5. Then graph u, v, and u plus v. So for the u, that would be -1, 8. So that, let me just put a little dot right there and then draw an arrow to it. So that is vector u. For v, go over by 2 and up by 5, put a dot, and then draw an arrow to that one. Now u plus v, there's two ways to do that. You could take this vector right here and put a copy of it right here. Take this vector and put a copy of it right here. And then when you connect this diagonal, that vector right there is u plus v. The other way to do it is u plus v just means add -1 and 2, so that's 1. Add 8 and 5, so that's 13. And then that would mean go over by 1 and go up to 13. And then draw that vector. Then for part B, find the angle between them. So in other words, before I drew the diagonal, this angle right here, how much is that angle? And you don't have to draw anything. You could just use the formula that goes cosine of that angle is equal to, for the numerator, you do the dot product. So you multiply this by 2, so that's going to be -2, plus you multiply this with 5, so that's going to be 40. And then you find the length of each vector. So the length is going to be the square root of each component gets squared. So -1 squared will be 1, and 8 squared will be 64. And then you do the same thing with this, which is going to be 2 squared is 4, 5 squared is 25. So then it says cosine of theta equals a +38 on top, and then the square root of 65, and the square root of 29 on the bottom. Then all that's left is do cosine inverse. So working in degrees, which sounds fine. Then take cosine inverse of 38 divided by, and because both of these are inside of a square root, you could just use one square root and say 65 times 29. And so the angle between them is 28.926 degrees. And then on to one last example, number 6. Where did these two functions intersect? Find out where, I forgot to write out, find where r equals cosine theta and r equals tangent of theta intersect. So the first thing I would do is graph it and get an idea. So make sure that it's in polar form, and then r equals cosine theta is one function. The other is tangent theta. And then because they're trig functions, we should probably go from 0 to 2 pi. The very biggest cosine gets is 1. So if I go from 0 to 2, that should definitely be enough to see the graph. And also on the y-axis, oh, you know what? I should go from -2 to +2, and then -2 to +2. And when I graph, I use radians, so I need to switch that over. And then go to the graph. There's one intersection, two intersections. So there's actually only two intersections, that one and that one, because they have to get to the same place at the same time. Now to find out where that is, you set them equal to each other. So when does cosine equal tangent? So for tangent, I could rewrite that as sine over cosine. And then the next thing to do is get rid of this fraction, multiply both sides by cosine of theta. So then this is going to leave cosine squared, and this is just going to leave behind sine of theta. Next, I need to get the trig functions to be the same. So I need the trig identity for cosine squared. And the trig identity to use is cosine squared equals 1 minus sine squared theta. And then because I have one term that's squared, one term that's not squared, and a number, we probably need to use the quadratic formula. So move everything to one side and set it equal to 0. I'm going to take everything and move it to the right side. So when you move this, it's going to become a positive sine squared, and then plus sine theta. And then we need to subtract 1 from both sides. Next up, we get to do the quadratic formula. So it's going to say sine of theta equals, and then the a is a 1, the b is a 1, and the c is a -1. So negative b plus or minus the square root b squared minus 4 times a times c, all divided by 2 times a. So this will be -1 plus or minus, let's see, this is going to be a positive 4 with one more means the square root of 5, and then that's over 2. So then I should find out what decimal values those are. So -1 plus the square root of 5, and that gets divided by 2. So 0.618. Also do the same thing when it has subtract the square root of 5. And a 1.6, a -1.6, sign never goes past -1. So that is not possible. The only solutions are going to come from this one. So we have sine of theta equals a 0.618. Got enough space over here to finish up. So sine goes like this, and then 0.618 is about right here on the y-axis, go across, and there's two solutions, which is good because when we watch the graph, there was two places where they intersect. So this first one comes from just taking sine inverse of the 0.618, and that is the number 0.666. And then once you have the answer 0.666, then the second one is going to be pi minus 0.666, which equals 2.475. So I got the two answers 0.666 and 2.475. And then I want to go back to the graph and see if that looks correct. So if you go back to the graph and put trace and then put 0.666. That should either be that point where they intersect or that point where they intersect. Okay, that's the first one. Excellent. And then 2.475, that should be the second one. Excellent. And if you want the x and y values, then it also gives you the x and y values. All right, that's review for exam 3.